This is automation during Tele-Op. I'm Unvis Botula. I'm the programming lead of 2220 Blue Twilight. And I'm just going to give a disclaimer. This is kind of programming heavy, so just so you know. So, yeah, I guess I'll get started. So, I just want to start off asking, does anyone already have, like, their robot automatically do something during Tele-Op? Like, having a preset elevator position or automatically lining up with the reef or just anything like that. Yeah.
Preset elevator position.
Yeah, okay.
Same thing like the elevator.
Yeah. So like, as you can see, like the pros of this is it's way quicker. You don't have to manually move the elevator up, right? It's just preset. You just click a button and it goes there. And it's just way quicker and way more accurate than manually pulling up your joystick and going to that specific spot, and you probably won't get it all the time. So for this one, I'm gonna talk about having your robot automatically go from point A to point B. So for the robot to move by itself during Tele-Op, as I said, it's quicker and more accurate, and it reduces cycle time, like for scoring, because it's just way quicker. And what I'm going to talk about right now is like snapping to a position. It's just like a term we made up, but it basically, because we're talking about going from one point to another point, we kind of just like say like it snaps to that point. That's why I'm going to just use snapping. So the example I'm going to use is snapping to the closest reef position. Just wherever your robot is, you click, you hold a button and it goes to that position. And it's just way more accurate than manually going there. So what you would need to do this is a limelight or any way so your robot knows where it is on the field. Otherwise, it won't know where it's going. And an IDE to code in, like WPIlib. You guys probably already have something like that. So I'm going to show code, except our code is public. So at Egan Robotics 2025 robot. And all the functions I'm going to be showing is in that specific folder, the drive commands.java folder. So yeah, you guys don't need to like memorize or take pictures or whatever, you just need to go here. So this is like a lot, but I'm going to break it down for you guys. So to snap to any position. So first, before we want to snap to any reef position, let's first like just snap to wherever we want on the field. So say our robot's here and we want to just go here. How do we do that, right? So, actually I'm going to use my mouse, it's easier to point. So what we do, we store the x, y, and omega. So here we're passing in where we want to go, and then we'll get that later, I'll show you. So this is our current position, and this is where we want to go. And this is just the x coordinate, and we store it in there. Same with y, and omega is the rotation of the robot. So this is where we are currently, and the desired position is where we want to go. You can ignore all of these. These are just its prints out statements. We used it for debugging. And then here, here, this is just a neat function. So chassis speeds, it basically just calculates the speed the chassis needs to go. We just plug this in. And it's pretty neat. It does all the math for us, and we get it. All we need to do is just plug it into our drive, which is our robot, and the robot will literally just go to whatever position we pass in as desired position. And this bottom stuff, it just, before we run this command, it just resets the PID controller so nothing goofy happens. And yeah, that's pretty much it. It's just like 5 lines of code, and then you can get your robot from going anywhere you want, just by holding down a button. So now, if we want to get the closest reef position, we can just use this. So now we have all the reef positions in an array. So that's what outer reef positions is. It's just a big array of every single position on the reef where you can score. So it's like 12, I think. And it's a for loop that just goes through each distance, takes where we are, and just subtracts it from the distance we are to there, and then just finds the closest one. It just loops through everything, and then returns whatever the closest one is. So now, when we put it all together, it's just this neat function. So we find the desired pose, where we want to go, which we just use the get closest reef position that I just showed, and that gets the closest reef position, and then that's where we want to go. And then using the snap to position where we can go wherever we want, we pass in that desired pose. And now if you use auto snapper and map it to like a button, say X, and you just hold down X, wherever your robot is, it'll just go to whatever the closest reef position is. And then you can score. And then on top of all this, now you can automate a ton of stuff. So the names are a little different because we renamed and stuff, but the algae snapper is the same thing as the reef positions, except because you can go to any position you want. You just need to have that array of stuff. So algae is just like right in between each the reefs is where the algae positions we have are, so it can pick up the algae. And then the Y, B, and A is where all like the neat automation happens. So first, the full snapper outer is similar to this. It does this stuff. So it goes to the closest reef position basically, and then we have presets for our elevator. So after automatically going to the closest reef position, then it moves the elevator up to L4, deposits the coral, and then brings it back down to L0. So just by holding Y, we can have our robot go to the reef and score basically. And then we can go even further with this. If you want, you can have it also go to, what is it? I'm blanking, but the thing where you can put the coral in where the human player is. But yeah, and then you can just go there and then continue looping back. And yeah, you can automate a lot of stuff, because especially with the reef, you have to do lots of precise movements to line it up, and then this just automatically goes there. It's way quicker. So, is there any questions so far? Yeah.
What do you do if there's like an object or something in the way of A and B, or do you just not use it in that scenario?
Oh yeah, I'll talk about that later. So that is one of the problems. Is right now we're not using the vision of the robot to see if anything's in the way. It just blindly goes. Like the limelight's only detecting the April tag, so it knows where it is. So yeah, I'll talk about that later. But yeah, that is one of the problems we face. Like say, the opposing robot like doesn't want us going and they just like block us, then we can't really do this. So now, this is a little bit more complicated, but we can use interpolation to make this way smoother. So this was our previous snap to position thing. And what it does, say this is the reef, it just goes smacks right into the reef every time, because it just goes to the reef and it doesn't really slow down, it just smacks there every time. So it is useful in some scenarios if you just want to go somewhere, it just like goes there, except you don't really want to smack into the reef every time. So you can use this, which is pretty similar. Like you can see we store the X, Y, and Omega, we restart the PID, lots of stuff. The only thing that's different is this part right here, where we take time as a variable. And the reason we do this is because, so for interpolation, basically it like makes a smoother path. And what we do, instead of just passing in the position we want, what we do, we pass in two different things. So the outer pose and the inner pose. So the inner pose is where we want to go on the reef. So if this is the reef, we want to go right here. But then the outer pose is a little bit just out in front of it. So what the robot will go, instead of just smacking straight into the reef, or if it's like to the side, it like scratches against the reef to go to where it wants. It goes to this place that's a little bit in front of the reef, so it's more smooth. It goes here and then here. And then interpolation just makes the whole process smoother, and it decelerates when it goes to the final inner pose. So what this does, it gets what time it is, and then it just starts counting like in seconds. I don't know if it's really seconds, but it just starts counting the amount of time, and then it just passes this in, and then the interpolate function basically just does all the math for us. It's pretty neat, just like the chassis speeds. It just does all the math to calculate everything, and then yeah. So just a couple additions with the interpolation, but then it's way smoother and faster basically. So using that, it gets, we called it fly snappy because it's kind of like faster, it's flying, but yeah, it's similar. This is the same as the getting the closest reef position. We just renamed it for this. And to get the interpolate time, because that's how much time we wanted here, what we would do, we just find, this is the position of our robot, and then we get the distance from where we want to go. So we just find that distance, and then this is like an if statement, basically. If it's greater than 1.5, we have it as 1.5, or else it's 0.75. We just played around with those values. And then it basically does the same thing as the previous one I showed you, but it does the same thing essentially. It's just more smooth, I guess. And yeah, that's like pretty much what that is. It's pretty simple. It's just like a few lines of code, and then like it does all the math for you, and then it makes the robot get from point A to point B automatically. And on top of that, like I showed you, you could just like have your elevator go up, score, and whatever. And you could just automate a lot of stuff, and it just makes it so much more quicker. And obviously, there are other ways that I haven't covered. This is just what our team specifically used for this year, is we were automating having a robot score by itself. And yeah, there are definitely other ways you can automate it. You don't have to go from somewhere. You can automate other stuff. You don't have to use this approach. There's obviously many other ways you can automate. And yeah, so this is what you talked about. So this is something we're currently working on, is having it, like you just said, like objects. We're right now like focusing on like other robots, because usually they're probably, at least for this year's game, there's not really an object in the way unless you're all on the other side, which probably you don't need to hold the button and go. You probably just need to bring it over to your side before holding the button. But yeah, so one thing we're working on is having the robot avoid other robots while in this autonomous state. So we're using AI to detect other robots and image recognition, and put in our limelight to detect other robots, and have it basically just move out of the way and kind of juke them out. But it's still a work in progress. And yeah, any questions? Yeah.
So other than April tags, what kind of sensors are you using to make some of this work?
So for this, all we need to know is where we are on the field. So all we need is April tags so we know exactly where we are on the field. And other than that, it just does everything else.
But what if a robot hits you when you pulled up to the reef and you're about to do this, but then somebody bumps you and you get dislodged? The IMU doesn't always pick up on that.
Yeah, that's true.
And the April tag may not be in view of your cameras at that point, so how do you recover?
Yeah, so that's also where the driver comes into play, because obviously they're going to be like watching what's happening and not like just holding the button and just falling asleep. So they're going to like rotate the robot probably and then just continue. And
Okay.
yeah, I don't think it's that big of a problem, because I mean, if a robot hits you, if it's from the opponent's team, then they're probably going to like try blocking you off too. But if it's from your own team, they're probably just going to move out of the way, and then we can just realign it again. But yeah. Any other questions? Yeah?
Have your team like experimented with path planner pathfinding, where you can just tell it to go to a point on the field and like avoid objects like the reef or?
Yeah, so we use Path Planner for like autonomous, like before the Tele-Op, just like for the actual autonomous, we use Path Planner. For this, during like Tele-Op, it was kind of hard. Like this was like our first idea was to use Path Planner. Like they had something like a path on the fly method where you could like use that so it basically from where you are in the middle of the game, it just like makes the robot go there. It was kind of complicated, so we ditched that idea and went with this. But yeah, we were experimenting with that in the beginning. Yeah.
So just to clarify, do you guys use Pathfinder?
Yeah, so for autonomous, we use Path Planner to do that. Any other questions? Yeah.
So how many cameras do you use to get a good estimate of your pose?
Currently, we just have one limelight, but it's been working out. We used this autonomous stuff in our last regional at 10K, and it was working really well. So that's all we're using right now. I guess for later games, if we need another camera, I guess we'll probably put it on. But for now, one is working for us. Any Any other questions?
So how much do the drivers fight you on this? In other words, the drivers insist they want to run the robot all the time.
Oh yeah, so yeah, that was kind of funny. So we went to 3 regionals. Our first regional, our driver didn't really trust the program and they did it all themselves. And then, I mean, it was kind of fair that by the time the first regional happened, it was kind of like working, but it was also a little bit like still in the making. By the second regional, we had it working, except the driver like used it sometimes to like help, but like didn't really use it that much. In the third regional, one of the drivers was a programmer who also helped with this, so he just like used it the entire time basically. That was kind of fun.
So what was better?
We did really well. So in the last regional, the 10K Lakes regional, when we actually used it, we did really well. So I guess it was better because it was like way faster. We got to do like, I think our peak was a little over 20 cycles in a match. So we were able to cycle really quickly. You have a question?
I wanted to ask, is your driver the one also doing these buttons, or do you have like another separate operator? Because for our team, we have the driver just driving around and the operator pushing those buttons.
Yeah, so we have the driver and the operator, which operates the elevator. For this, we had it on the driver's controller, except if we wanted, we could have had it on the operator's controller, just like preference, who wants what, and like what buttons they want to put it on. But we just had it in the driver controller because we just felt like if they're driving, they can also adjust and stuff. But yeah. Yeah.
How do you ensure you guys get accurate vision readings for just one camera?
Yeah, so that was a problem we faced in the very last match of 10K and the, semifinals. Our camera became blurry and it couldn't read any of the April tags, and we ended up losing because it couldn't really detect anything. So yeah, that is a problem we faced. And I mean, for now, because we have the April tag, we have it positioned like, so it can see pretty well, and if it can't see, our driver can just rotate the robot so it knows where it is on position. I'm on the field and then use the thing and it knows where it is, because you can just rotate the robot so the camera is facing an April tag. So yeah, for now it is working, except say like when the limelight starts to not work or it's too blurry to read anything, then we face problems because we don't really have a backup. But yeah.
Are there other ways to know where the robot is on the field other than the limelight or April tags?
Not that I know of actually. I put like other ways just on the slide, but we just use a limelight and use that to detect April tags. There are probably other ways, but I don't really know.
I'm just gonna like ask like if ultimately
Yeah, I mean, I need to look that up. We just use limelights. Not really sure if there's other things, but there might be.
Do you guys have any kind of filtration system for the data that comes in for vision, or do you guys just take everything?
What?
For all the April tag data that comes in, do you guys filter any of it based on like ambiguity or anything, or do you guys take it all in?
No, we just like, it just detects the April tag cause, I mean, limelight's pretty neat, like it knows the distance from where the April tag is and stuff, so it knows where it is on the field. So, we just look at all the April tags on the screen, honestly. We don't really need to filter them out right now, but yeah.
Anything else you'd suggest automating, like aside from going to point A to point B, or like the elevator?
So, for this game specifically, obviously for the other games it could change, I have no clue. But for this game, this worked pretty well to like automate honestly the entire game, because we would go from point A to point B like the reef, and then we would raise the elevator, which I guess you could count as automation. We raise the elevator, deposit the coral, bring it back down to L0, and then I guess we could automate going to the source, and then having it, the human wait for a little bit for the human player to drop it in, and continue cycling. It wasn't ideal. We had to just go back to the source and then go to the next thing, and then like have it remember where it was so it doesn't go to the same place. And then go for the entire reef, but we didn't have enough time to really implement that. But, I mean, that is honestly the entire game. We didn't really focus on algae that much, but we can still go to the algae with using the same thing and do the stuff. For other games might be different, but for this game, there's not really much else, I feel. Yeah.
Would you ever like misalign with your board?
In the beginning, when we were still like making it, yeah, but after like it was good, I don't think we ever misaligned because it knew exactly where it was on the field, so it was able to do it pretty accurately. Yeah.
So you guys don't use any sort of like telemetry from like the motors to figure out where you guys are on the field? Or-
Yeah, we use odometry and stuff. That's like in the like when we were making the like having the limelight and like the motors and everything, we used odometry and stuff to know where we are. So that was kind of like a background thing. I didn't show that though, but yeah. Anything else? All right then. Yeah, I mean that's pretty much it. It was kind of a short one compared to the other ones, but yeah.
Thank you.